Okay, guys, so we are working on force. What is a force? And how does force change the speed and direction of the object? All right, our standard tells us that we need to obtain, evaluate, and communicate information to explain the effect of a force. We know force is a push or a pull in the movement of an object. All right, and that means the change in speed and direction. All right, so today we're going to read a book. All right, this book is found in Epic, so you can read this book yourself at any time. It's called Give It a Push, Give It a Pull, A Look at Forces. And it's by Jennifer Boothroyd. She is the author of this book. It says, learn all about matter, energy, and forces in the Exploring Physical Science series. All right, and it's a 500 Lexile, so that means it's in our range for second grade. All right, so let's read. Most of the time, you can see the cause of a force. A person pushes a swing, a truck pulls a boat. So we hook the boat to it and the truck pulls it. When a truck pulls a boat, you see the truck doing the pulling. You can actually see it. When a person pushes a swing, you can see their body physically doing the pushing. Pushes and pulls. A force is a push or a pull. Forces are always with you. They are all around you. If you've seen someone pushing a swing, then you've seen forces at work. Sometimes the cause of a force is invisible. Wind pushes leaves across a sidewalk. The wind is invisible. Gravity pulls a paper airplane down. Magnetism holds magnets against a fridge. You guys learned about magnets in first grade. Magnetism pulls the magnet against the fridge. Magnetism is invisible. Putting things in motion. Forces put things in motion. Pushing the pedal makes the tire spin. So when you put force to it, how does the tires move? By spinning. That's right, they spin round and round and round. Pulling a wagon makes it roll. So how do the wheels move? They spin or roll. That's right, they're round as well, so they can spin. Pushing and pulling your pencil lets you write your name. Thanks to forces, you can write on a sheet of paper. All right, think about your pencil. What motion do you normally use when you write? You normally go up and down, right? Yes, we do. To write. A push moves something away from the force. This toy car moves away from the boy when he pushes it. So a push will take it away from you. A pull moves something closer to the force. This rope moves closer to the girl when she pulls it. So pulling makes it come closer to you. They are opposites. Stronger forces can make things move farther. So the stronger the force, what's going to happen? Yes, the farther it should move. You can throw a ball across the yard with a strong push. A strong force will make a football sail far away from you. A gentle force makes things move only a little. A little push gets this boat on its way. A gentle push will make a toy boat move a short distance from you. So the stronger the force, the farther it will move. Go back. Sorry guys, it skipped one else. An object's weight can change the force needed to move it. It takes a lot of force to pick up a heavy suitcase. It takes only a little force to lift a light feather. Direction and speed. A force makes something move in one direction. Another force can change it. A pitcher throws a ball to the batter. The batter hits the ball. The ball flies in a different direction. Forces change the speed of things. A strong force can make something move quickly. A strong push of bobsled makes the sled move very quickly. We have a little reader that we're going to read Monday that has a bobsled team on the front. They know a lot about force and motion. A strong wind makes a sailboat race across the lake. A hard pull on the wheels makes a wheelchair speed along the ground. The racer pulls hard on the wheels of his special wheelchair so he can win the race. Forces make things stop moving. A brick wall will stop a ball. The wall has a lot of force. It pushes against the ball. A tennis ball will stop moving forward when it hits a brick wall. A glass window may not stop a ball. Glass pushes against a ball too, but the ball pushes even harder than the glass. What happens then, guys? Yes, it will break it. A glass window has less force than a brick wall, so a ball may sail right through it. That's bad news for whoever hit that ball, right? Yes, they have a broken window to pay for, I'm sure. An object's weight can give an idea of the force needed to stop it. It takes a lot of force to stop a train. Because a train is what, guys? Very big and very heavy. Only something with a huge amount of force could make this great big train stop. It takes a little force to stop a ping pong ball because it is what? That's right, it's very small. All right, we're going to stop here because we're not ready to talk about friction yet. All right, now we have been talking about force being a push or a pull. I think you guys have pretty well gotten that. When we apply force, the object will move according to the amount of force that you put on it. Now let's talk a little bit about the way things move and its direction. So, all right, think about things. We talked about it a little bit yesterday. All right, things can move in different ways. All right, some things will move fast, some will move slow. Some things will move straight in a line. Some will move zigzag or side to side. Some things may go up, some may only go down. Some may go up and down, right? All right, some things may actually go round and round and round, just like the wheels on the bike or on the wagon. Okay, so you're going to have to think about those things some. All right, so let's look here. Motion and direction. All right, you're going to look at the picture of the object using force and decide about its motion. All right, you're going to have 3 words that you can choose from. All right, you'll have, like for number 1, I have fast, slow, or spin. All right, how would you describe the cheetah's motion? Fast, slow, or spin? All right, the next one, you'll look at the basketball player. He has a ball that is moving. All right, they put it on their finger and it moves. All right, you have spin, zigzag, up and down. How is that ball moving? The motion of it when force is applied. All right, the next one. Snail. Look at that snail. How would you describe the motion of that snail? All right, the balloons. When some force is applied, think about the motion of the balloons. Okay, once you know, you may complete them all. Okay? All right, you can do these more than one time. As a review, we will take a grade next week for the first time on force and motion. All right, study hard.